that. So for section 3, we're adding and subtracting rationals. And again, that means being able to add and subtract fractions. So let's just review real fast about what that even looks like. If I want to add 1/2 and 1/3, what has to be true in order for me to even be able to add fractions?
Yeah, she said.
They have to have a common denominator. Usually we're looking for the least common denominator. So if I'm looking at 1, if I'm trying to add 1/2 and 1/3, typically what we're going to do is multiply top and bottom of both of them by whatever it takes to get that common denominator. So that means, okay, well, I'm going to multiply this one top and bottom by 3, this one top and bottom by 2, so that I end up with 3/6 plus 2/6, which would get me 5/6. Does that look familiar to everybody? Okay. So again, once the denominators match, then I just add the tops and the bottom denominator stays the same. That's what we're going to be looking at for a lot of today. So for part 1 here, or number 1, they want us to find the common denominator. We've got 2/3, 1/2, 3/4. Anybody know what the least common denominator is here? It would be 12. Now that's different than just doing 3 times 2 times 4, right? That would be 24. That's not the least common denominator. There's a couple ways you can come up with that 12. I'm going to show you the most broken apart, like step-by-step method for this, okay? Some of you will be able to do this in a faster method. That's great. But I want everybody to see exactly what's going on here as we go forward. This 4 is made up of 2 times 2. Everybody's good with that, right? So when we build least common denominators, we're going to think of it like a box of Legos here. We're going to say, right now my box of Legos is empty. I have nothing to build with. So I come to the first fraction and I see this 3. I'm going to take, I want a different color there. Let's try that again. There we go. So I see a 3 right there. Right now my box is empty. So I'm going to take that 3 and put it in and say I need at least a 3 to be able to make these denominators. Then I go to the next one. It's got a 2. I don't have any 2s yet. So I'm going to get a 2 and say I need a 2 in my box of Legos here. When I get to the third one, it needs 2 2s. I already have 1, so I just need 1 more 2. So my box has 1 3 and 2 2s in it. That way, when I go to make the first one, I can take a 3 out and make it, and then I put the 3 back. Come to the next one, I need to make a 2, I take a 2 out, and then I put it back. When I make the 4, I need to take both 2s out to make the 4. But then I put them back. Every time when I'm making one of those fractions, I take the pieces out I need, and then I put them back in for making the next one. Does that make sense to everybody? This is probably even more basic than what you're used to doing, but getting that idea into our head is going to help when we get to the more complicated ones in a moment. So let's look at the next one. We're going to do the exact same thing. 3 fractions, all with variables on the bottom. In order to make the very first one, I come up here, I look at this, and I say, okay, right now my box is empty. This fraction has a y, z squared in it. So I need at least a y and 2 z's in my box. So y times z times z. That will let me make the first fraction. Then I come to the second one, and I see xy cubed. Well, I already have 1y, but I need 3 here, so I need 2 more. Y and y. That gets me 3 y's. And then I don't have any x's yet, so I need to add an x in there. So now I have all the pieces I need to make the first 2. So now I come to the third one. And let's see, there we go. XY. Well, I already have an X and a Y. I have everything I need to build it already. So I don't have to add anything into my little box of blocks. Does that make sense? So now I can rewrite this and say, okay, my least common denominator is X y to the third z squared. That's my least common denominator for this. Has all the pieces I need to make all three fractions. I don't have to make all the denominators at once. I can put the pieces back before I make the next one. Now, it's important to realize then that these blocks that we're using, these blocks are the factors. So for number 3, Jackson, you doing okay? For number 3, the factor on the first one is m plus 2, the whole thing. That is one factor. I need that whole factor, m plus 2. When I get to the second one, yes, it has an m in it, but I'm going to say that they have nothing in common because the first one is m plus 2 altogether. The second one is m minus 7 altogether. It's an entire piece. The least common denominator for this is m plus 2 times m minus 7. I need both pieces. Now, that one's kind of nice in that there was nothing to factor there. The next one is going to require a little bit more work because these factor. So 5 over x squared plus 2x plus 1. The bottom right here, x squared plus 2x plus 1 factors into x. Actually, let me make myself a little bit more room there. X plus 1 times another x plus 1. That way I multiply it out. I get a 2x in the middle. 1 times 1 is 1. There's the factors for the first one. For the second one, I need to factor out, looks like 3x. They both have a 3x in them, so I can take that out. 3x, left with an x plus 1 behind. So when I'm putting together my least common denominator, I could start with the red one and say, okay, I need all the pieces in there because right now it's empty. 3 times x plus 1. I need all those pieces. And then when I get to the other one, this one needs 2x plus 1s. I already have 1. I need 1 more. If I went the other way and started with the x plus 1s, I'd have 2x plus 1s. I go to the red one here. I say I have enough x plus 1s, but I need a 3 and an x. So that I have all the pieces I need to make either fraction with as little repetition as possible. So I can either leave it like this, or I could rewrite this as 3x times x plus 1 squared. If you wanted, you can write it like that to make it a little bit more condensed. So now that was all just kind of set up. Now we're actually going to try some problems. We're going to try to add some fractions. We're going to start with the easiest ones where the denominators already match. Okay, so for number 5, the denominators already match. So all I have to do is say, okay, my new fraction is going to be over 2x plus 3. And the top is going to be the top of this one, 5x. Plus the top of the second one. Oops, let's go back. Oh, there we go. Plus the top of the second one. X plus 9. Now, I am going to put that x plus 9 in parentheses. Here, it doesn't actually matter. Okay? But for subtraction, that parenthesis is going to be super important. For addition, it doesn't matter. But I'm going to put it there just as a reminder. Now, I'm going to combine like terms. The top, 5x plus x. Okay, be careful here. What is 5x plus x? 6x. Again, typically I get two answers. I get 5x squared and I get 6x, right? 6x is what we're looking for because I'm just adding them up. 5x's plus 1x makes 6x. It's 5x times x that gets me 5x squared. So be careful there. We're doing a lot of both adding and subtracting and multiplying and dividing. So here, 5x plus x is going to make 6x. And then you just have that plus 9 on the end over 2x plus 3. No, I'm not done yet. Because the top factors. Does everybody see that both of the terms in the top have a 3 in them? So I can take a 3 out. Factor that 3 out. That's going to give me 3 times 2x plus 3 over 2x plus 3. And now we're going to reduce just like we did the last couple days. I have a 2x plus 3 on the top and the bottom. That reduces all just to 1. One big 1 right there. And I'm left with just 3 over 1, or just 3. That's all that's left over here. So it reduces quite a bit. Now, let's try number 6. Same exact idea. Denominators already match. Add the tops, so the denominator is still going to be n squared plus 2n minus 3. The top is going to be n plus 3. Right now, I can't simplify anything because the bottom isn't factored. So if I factor it though, n squared, I'm going to write the, let's see, n squared plus 2n minus 3 would factor into n plus 3 times n minus 1. Right, that multiplies to -3 and adds up to 2. I'm looking for what multiplies to 3, adds to 2, 3 and -1. The top is still just n plus 3. I see an n plus 3 on the top and the bottom. Those reduce to 1. So this whole thing right here reduces just to 1. I'm left with 1 over n minus 1. One over n minus 1. All right, now in second period, I let them try a subtraction one before I showed this next example, and we had a lot of mistakes on it, which is very typical. This is why I'm gonna, instead of having you guys try it out and find it out yourself, I'm gonna show you first and then have you try it. Remember how I just told you that when I write this, if there's more than one thing on the top of the second one, I need to put it in parentheses, and that's important for subtraction. Here is where it's going to come up. The denominators already matched, so I'm over 10n minus 4. 10n minus 4 on the bottom. The top, I have 9n minus 3. Minus 3n plus 5. Here's the issue. Most of us remember to subtract the 3n, but it's 50-50 about whether we remember to subtract the 5. We need to remember that both of those are part of the subtraction. So at this point, I need to distribute that the negative n. I need to make this a -3n and a -5. Does that make sense to everybody? Do not forget that step. So the top, the 9n minus 3 doesn't change. No. 9n minus 3. I can combine like terms. This is all still, let me go ahead and write it just so we don't forget. All still over 10n minus 4. So then I'm going to do 9n minus 3n, which would be 6n. -3 minus 5 would be -8 over 10n minus 4. So close to being done. So close to being done. Again, Jackson, stay with us. Take notes, all right? Looks like I can factor out a 2 from the top. Make this 2 times 3n minus 4. And on the bottom, looks like a 2 goes into both of those also, leaving me with 5n minus 2. So because I have 2 on the top and the bottom, I can simplify that. 2 over 2 is just 1. Devin, you doing okay? Got it. 2 over 2 is just 1. I'm left with a final answer of 3n minus 4 over 5n minus 2. There's my answer. Let's try some homework problems. The homework for tonight, and really, again, we're not going to finish this in one lesson, so we'll finish it up tomorrow. But we're going to be doing 1 through 21 odd. Right now, let's try numbers 1 and 3. Okay, everybody? Try numbers 1 and 3. 1 should be real fast. 3 is much closer to what we just did there on example 7. All right, so for number 8, I have a little bit of an issue here in that the denominators don't quite match yet, do they? But they're real close. The second one is the same as the first one, but it's been switched and the signs are opposite. Anybody remember what we learned? We have a trick for dealing with this. Either of you? Take a negative out. So everybody's full attention because this is going to happen a couple times on the homework. This 4 minus q squared. I'm going to rewrite that. This first one's going to stay exactly the same. Not going to touch the first one yet. 7q minus 3 over q squared minus 4. Not touching that one, but the second one, I'm going to rewrite as negative q squared minus 4. Take that negative out of both terms so that the q squared becomes positive, the 4 becomes negative. I switch the order, and now they almost match. But now I've got a negative on the bottom there. So now it's time to go back and talk a little bit about just basic fraction stuff again. Class, if I have 1 over negative 2, I'm going to write it over here, just again, off to the side. If I have 1 over negative 2, is that the same as negative 1 over 2?
Yeah.
Those are the same. What about if I put the negative on the top? Negative 1 over 2. Those are all the same. Does everyone understand that that negative can go in 3 places and not change what I'm talking about here? So right now I've got this extra negative right here. I can put it in one of 2 places to move it out of the denominator. I can either put it right in the middle. So take this, move it up here and make this a minus. That would be fine. Or another option is to just move it up to the top. Put it up here and make this negative 6q plus 5. Essentially apply it to both of the top terms. That's probably going to be the best option here. Other times though, especially if this was a negative, it would be better to apply it right there. Negative and a negative becomes a positive. That's going to make our lives a lot easier. But in either case, I just need to get that negative out of the denominator so that the denominators match. Does that make sense to everybody? Factor a negative out so that they actually match. Move that negative either in the middle or up to the top. So now denominators match. I can go ahead and do 7q minus 3 minus 6q plus 5 all over q squared minus 4. That q squared minus 4 is a difference of squares. But actually, before we do that, let's do 7q minus 6q. 7q minus 6q would be 1q. Negative 3 plus 5 would be plus 2. And then the bottom is a difference of squares, just like I was starting to say a moment ago. That is going to factor into q minus 2 times q plus 2. Does that make sense? Are we okay so far? Q plus 2 on the top and the bottom, that whole factor cancels out. I'm left with 1 over Q minus 2. There's my final answer for number 8. Now we actually don't have a ton of time left. We got about 10 minutes, 11 minutes. Good. So I'm going to show you number 10, and then we're actually going to stop and you can try a problem or two on the homework, okay? So everybody look at number 10. Now the denominators don't match. So we're actually going to go all the way back to what we did at the very beginning. Here, remember that this x plus 2 is one factor that the other one is missing. My least common denominator here is going to be x plus 2 times x minus 3. Does that make sense to everybody? I need both denominators together to have all the pieces. So now at the very beginning, we talked about what if I want to do 1 over 2 plus 1 over 3? I multiply by whatever I need to get those denominators to match. So in this case, I'm going to multiply the first fraction by x minus 3, top and bottom. And I'm going to multiply the second fraction by x plus 2, top and bottom. That way, I end up with a common denominator on the bottom of x plus 2. Let's keep it in the same order. X plus 2 times x minus 3. That's what I have on both denominators. So that's what's going to be on the bottom of my answer so far. And then on the top, I'm going to have 3 times x plus x minus 3. You can write it in either order. I'm going to put the 3 out in front. 3 times x minus 3 plus 2 times x plus 2. Now, I had some students ask in the last class, can I just cross off the x minus 3s? I see one on the top and the bottom. Why can't I do that? Yeah, does everybody see that this addition sign is linking pretty much everything on the top? I have 3x plus or 3x minus 3 added to 2 times x plus 2. Right now, everything on the top is part of one big addition problem. So before I can do anything else, I need to distribute and combine like terms. So here I'm going to do 3 times x, 3x. 3 times negative 3 is negative 9. 2 times x is 2x. 2 times 2 is 4. All over that same x minus 3 and x plus 2. And now I can combine like terms. 3x plus 2x makes 5x. Negative 9 minus 4 is negative 5. So I'm left with x minus 3 times x plus 2 on the bottom. And I could factor a 5 out of the top. I could write that as 5 times x minus 1. But do you guys see how nothing simplifies? So I could actually stop right there. This would be fine. Or I could write it as 5 times x minus 1 over x minus 3 times x plus 2. Either of those two is correct because nothing reduces. Now you guys have about 8 minutes left. I want you to try a couple of these. Specifically, the best ones to start with for us are probably number 7 and 11. Try 7 and 11 right now. Try 7 and 11. If you want to work ahead, the homework is 1 through 21 odd, but we haven't gone over all the examples yet. But if you don't do anything tonight, you're going to have a lot of homework tomorrow. Does that make sense? So look through any ones that you can do, hopefully 7 and 11 right now. And maybe 1, 2 more. You should be fine then if you get those done. You won't have tons of homework tomorrow.